Hi everyone, in this video we're going to look at solving modular equations. I have 4 examples here, and for those of you in my number theory class, this appeared as one of the questions on one of your tests recently. And so we are finding a solution to these equations. So 29 is equivalent to some number mod 3, and we're supposed to find the least possible non-negative number that would make this a valid equivalence. So first, let's talk about what it means here. When we say 29 is equivalent to some number mod 3, what we're looking for is a remainder when 29 is divided by 3. Algebraically, we can say that like this. 29 is 3 times some multiple plus a remainder of x. And so if we rearrange that, we can say x is 29 minus 3 times some number r. Now, if I want x to be as small as possible, then I'm looking for some number that I can multiply by 3 that will be just less than 29, as close to 29 as possible without going over. And that number, of course, is going to be 9 because 3 times 9 is 27. And so if we let r be 9, then x is 29 minus 3 times 9, or 29 minus 27, which is 2. So the answer we're looking for is 2. Let's try the next example. So we have 3,498 is equivalent to some number mod 5. So in other words, when 3,498 is divided by 5, we want a remainder, the least possible non-negative number. So one way to write that is 3,498 is equal to 5 times r plus x. We can rearrange that and say that x is 3,498 minus 5 times r. And so if you divide out 3,498, you will find that 5 divides into 3,498 699 times, with a remainder, of course. So we can say that x is 3,498 minus 5 times 699, and that's equal to 3. So that is the remainder. And so that's our answer. So the numbers we are looking for is basically the remainder we get when we divide the number by the mod. Let's try the next example. 3,498 is equivalent to some number mod 10. So in other words, when I divide 3,498 by 10, what is the remainder? This will be different than B. In B, where we're dividing the same number by 5, now we're dividing it by 10. So 3,498 is equivalent to 10 times some number plus our remainder, which is what we're looking for. So we can rewrite that. So 10, it turns out that 10 divides into 3,498 349 times with a remainder of 8. And honestly, these last 2 examples that we've done, you could really just look at the number. We know that if a number is divisible by 5, then the number ends in 5 or 0. Example B ends in an 8. So we know that 3,495 is divisible by 5, and so this would just be 3 more. Similarly, in example C, we have 3,498, and we know when a number is divisible by 10, it ends in 0. So if this were 3,490, it would be divisible by 10. But with the 8, we know that that is actually the remainder. So while I'm showing you all of this algebraic solution, or how you can think about it algebraically, you may not necessarily need to do so. This next example is interesting because we do have a negative number, and I want my answer as the least possible non-negative number. And I'm dividing by 11, and we know when we're working in mod 11 that there is a cycle that repeats every 11 so every 11 numbers. We can think of this as if we add 11, then our answer should be the same. And if we add 11, our answer should be the same, and so forth. And so if we add 11, if we continue to add 11 to negative 23, we'll eventually get to a positive number. And the first positive number that we'll get to is 10. So let me talk you through that. So negative 23 plus 11 would be negative 12. Negative 12 plus 11 is negative 1. And negative 1 plus 11 gets us to our positive value of 10. So now that we have this in terms of a positive, we can proceed in the same manner as before. So we know that 10 is going to be divided by 11, and we're finding the remainder. Now, of course, 10 does not divide by 11, so the R value is just 0. So 11 times 0 subtracted from 10 just gives us 10. So 10 is in fact the remainder. Let's look at another example. This one says 2 is equivalent to x mod 31, where x is a positive integer. So 2 is divided by 31, and we have a remainder. Okay, so we can write this as 2 is 31 times some number plus x. Well, if you think about this, we rearrange it into x is 2 minus 31 times r. The r values that are going to make x positive are 0 and the negative integers. If r is a positive integer, then x will certainly be negative. So we're going to plug in 0, -1, -2, -3, and so on. And so these are the values that we'll get. If r is 0, 2 minus 3 times 0 is 2. If r is -1, 2 minus 31 times -1 is 33. If r is -2, 2 minus 31 times -2 is 64, and so on. So I hope this was helpful. Please reach out if you need further instruction on solving modular equations.